Have you ever wondered how your car's engine works? What makes it roar to life with just a turn of a key? Well, it's not magic, but a marvel of engineering, the gasoline engine. This mechanical wonder that powers our vehicles is a complex system of moving parts and chemical reactions all working together in harmony. Our journey today will take us through this intricate labyrinth, breaking down the workings of a gasoline engine into bite-sized, easy-to-understand segments. We'll explore everything from the heart of the engine to the exhaust, the fuel-air mixture to the spark plugs, and everything in between. This isn't just a journey for car enthusiasts or mechanics, but for anyone with a spark of curiosity about the world around them. It's a testament to human ingenuity and the relentless pursuit of progress. So buckle up as we dive into the intricacies of a gasoline engine. At the heart of your car's engine are the cylinders. These are the powerhouses, the workhorses that bring your car to life and keep it humming along the highway. But what exactly is their role? Let's dive in. Imagine the cylinder as a mini combustion chamber. It's here that the magic of the four-stroke combustion cycle happens. This cycle, which is the very pulse of your engine, consists of four key stages: intake, compression, combustion, and exhaust. First up is the intake stage. This is where the engine breathes in. The cylinder fills up with a mixture of fuel and air, the life-sustaining ingredients of the engine. The piston, a kind of plunger inside the cylinder, moves down, creating a vacuum that sucks in this fuel-air cocktail. Next, we have the compression stage. The piston moves back up the cylinder, squashing or compressing the fuel-air mixture. This is a bit like squeezing a sponge, but with much higher stakes. This compression makes the mixture highly explosive, priming it for the next stage. Then comes the combustion stage, also known as the power stroke. This is where things get fiery. A spark from the spark plug ignites the compressed fuel-air mixture. The resulting mini explosion pushes the piston down with great force. This movement is then converted into the rotational energy that turns the wheels of your car. Finally, we arrive at the exhaust stage. The piston moves back up the cylinder, pushing out the spent gases, the byproducts of the combustion, through the exhaust valve. Just like you, the engine needs to breathe out after doing its work. So, there you have it. From taking a deep breath of fuel and air, to compressing this mixture, igniting it for power, and breathing out the leftovers, these four stages make up the life cycle of your engine's beating heart. It's a cycle that repeats thousands of times per minute, powering your journeys big and small. Now, what exactly is this engine burning to keep your car moving? Let's delve into the essence of what's happening under the hood. Imagine your engine as a hungry beast. Its diet? A carefully balanced meal called the fuel-air mixture. This blend is the lifeblood of your car's engine, the secret sauce that keeps those wheels turning. The fuel-air mixture is, as you might have guessed, a combination of fuel, typically gasoline, and air. These two elements are brought together in a finely calibrated dance, choreographed by either the carburetor or the fuel injector. They control the amount of fuel and air entering the engine, striving to maintain the perfect balance for combustion. Picture the carburetor as a master chef, diligently preparing the fuel-air mixture. It mixes air and fuel in the correct proportion, allowing it to be easily ignited. The carburetor ensures that not too much nor too little fuel is used. It's all about precision, about achieving that ideal ratio of 14.7 parts of air to 1 part fuel. This optimal mix is what makes your engine run smoothly and efficiently, ensuring you get the most out of every drop of gasoline. But in modern engines, the carburetor has largely been replaced by the fuel injector. Think of the fuel injector as a high-tech chef using advanced technology to deliver the fuel-air mixture. It sprays a fine mist of fuel into the engine's intake manifold, where it mixes with air before being drawn into the cylinders for combustion. The fuel injector's precision and control allow for a more efficient and clean burn, improving fuel economy and reducing emissions. Whether it's a carburetor or a fuel injector doing the work, the goal remains the same: to create the perfect fuel-air mixture. This mixture is then ignited by the spark plug, causing a mini explosion that pushes the pistons down and turns the crankshaft, which ultimately drives your car forward. So, it's the perfect blend of fuel and air that keeps your engine humming. Getting that blend just right is the key to a happy, healthy engine, and a smooth, efficient ride. But how does this fuel-air mixture ignite? Enter the spark plugs. Spark plugs, often overlooked, are the unsung heroes in the symphony that is an internal combustion engine. They have one job, but it's a job of paramount importance: igniting the fuel-air mixture. It's like striking a match at the heart of the engine over and over again, thousands of times per minute. Imagine the spark plug as a miniature lightning bolt. When it's time for ignition, an electrical current leaps across a tiny gap at the plug's end, creating a spark. This spark sets off a mini explosion as the fuel-air mixture combusts. The resulting force pushes the engine's pistons, turning the crankshaft and ultimately driving the wheels of the vehicle. The timing of this ignition is a finely tuned dance, choreographed to the millisecond. Ignite too early and the engine can knock or ping, which is like it's coughing or stuttering. This can lead to inefficient fuel consumption and even damage over time. Ignite too late and you lose power as the fuel doesn't burn completely before the exhaust phase. That's where the engine control unit, or ECU, comes into play. Using a myriad of sensors throughout the engine, the ECU calculates the perfect moment for the spark plug to fire. It's a constant balancing act, adjusting to factors like engine speed, load, temperature, even the air-fuel mixture itself. And let's not forget the durability of these spark plugs. Despite the intense heat and pressure, they keep sparking mile after mile. Typically, a spark plug can last anywhere from 30,000 to 100,000 miles. That's like going around the Earth more than once. In the grand scheme of an engine, spark plugs may seem small and insignificant, but without them, the engine wouldn't run. They're the silent spark that brings the power of an engine to life, triggering the chemical reaction that propels your vehicle forward. So the spark plugs are the unsung heroes, igniting the fuel-air mixture at just the right moment. Once the fuel burns, what happens to the waste gases? That's the question we'll answer in this segment. When the fuel-air mixture has been ignited by the spark plugs, it creates a mini explosion within the combustion chamber. This explosion generates power, but it also produces waste gases. Now, these gases need to go somewhere, right? They can't just hang around in the engine, clogging things up. This is where the exhaust system comes into play. As the piston moves up following the explosion, it pushes the waste gases towards the exhaust valves. These valves, much like the intake valves, have a crucial job to do. They remain closed during the intake and compression strokes, but at the exact moment when the waste gases need to be expelled, they swing open, providing an exit route. Timing here is key. If the exhaust valves open too early or too late, it can significantly impact the engine's performance or even cause damage. But it's not just about getting the gases out of the engine. The exhaust system also needs to ensure that these waste gases are expelled safely. You see, these gases can be quite harmful, both to the environment and to people. The exhaust system is designed to channel these gases away from the engine and out of the vehicle, reducing their impact. The exhaust system also includes components like the catalytic converter, which helps to break down harmful gases into less harmful substances before they're expelled. Then there's the muffler, which reduces the noise produced by the exhaust process. Once the waste gases are safely out of the engine, the exhaust valves close again and the cycle begins anew. The engine is now ready to take in a fresh batch of fuel-air mixture and start the process all over again. And just like that, your engine breathes out, ready for the next cycle. In our next segment, we'll wrap up our journey through the inner workings of a gasoline engine. Stay tuned. In a nutshell, your car's engine is a symphony of perfectly timed processes. The heart of this orchestra is the cylinders, where all the magic happens. They dance to the rhythm of intake, compression, and combustion, the three-stroke cycle that powers your vehicle. The fuel-air mixture, the lifeblood of the engine, is precisely prepared to ensure the most efficient burn. This mixture is then ignited by the spark plugs, the maestros that trigger the combustion, leading to the powerful explosion that drives the pistons. Finally, the exhaust system clears the stage, getting rid of the spent gases and paving the way for a fresh cycle. This efficient system is what makes your car move, turning fuel into horsepower with a mesmerizing rhythm. So there you have it, the fascinating world of gasoline engines, demystified. Don't forget to like, subscribe, and share this knowledge with your fellow car enthusiasts.